Here we will solve problems on limiting and excess reactant and also the leftover after the reaction is complete. So here is the problem. Determine the limiting reactant and the excess reactant if 5 moles of methane reacts with 8 moles of oxygen. So we are given 5 moles of methane. This is the information I'm getting from the question, from the problem. We have to figure out which of these substances, like is it going to be 5 moles of methane or is it going to be 8 moles of oxygen, which is going to run out first in the reaction, meaning which is going to actually control the reaction or limit the products. These are the products here, carbon dioxide and water. So you always start out with the balanced equation. You have a balanced equation, and from this balanced equation, this is actually a combustion reaction. So the balanced equation shows that we need 1 mole of methane for 2 moles of oxygen. So here is the equivalent, guys, and I'm getting these numbers from the coefficients of the balanced equation. And this equivalent is going to give me two fractions. These are the mole ratio, and from this one, which fraction am I going to pick, which conversion factor I'm going to pick, depends on which substance do I have to determine the moles for which substance. So here, let's start out with this methane. So we are given 5 moles of methane. That's the amount we are given. And for with these for 5 moles of methane, how many moles of oxygen we will consume? So that's what we need to figure out. Well, we are already given from the mole ratio that for every 1 mole of methane, we need 2 moles of oxygen, right? So since we have to figure out the moles of oxygen, I'm going to use this conversion factor, and going to cancel this and this. So what are we doing here? We are figuring out that by using 5 moles of methane, how many, or if we use 5 moles of methane, which is actually given moles of methane, how many moles of oxygen we will need for this reaction. Well, when you solve this, you are going to get 10 moles of oxygen, and these are the moles of oxygen which are actually required when you're using 5 moles of methane. But look at the here, how many moles of oxygen are given? We are given only 8 moles of oxygen, 8 moles, right? But how many we need? We need 10 moles. So we have, what do we have? We have 8 moles of oxygen, and how many moles of oxygen are needed? 10 moles. So we don't have enough, correct? Provided in the reaction. So this is the one, so oxygen is the one which is going to limit our reaction. So our limiting reactant is oxygen, and since our limiting reactant is oxygen, our excess reactant will be CH4. I'm going to write it like this: 8 moles of available oxygen is actually less than 10 moles of oxygen needed. Here you go. And that is the reason that oxygen is our limiting reactant, and it is going to run out first. It's going to determine the amount of products in the reaction. And excess reactant, which is CH4 here, is the reactant which is available more than it is required. We don't have to actually solve anything for excess reactant here, because this problem is only asking which is the limiting reactant, which is the excess reactant. So since you figured out the limiting reactant, the other one is the excess reactant, and there will always be excess reactant left over after the reaction is complete. Let's solve another problem here. In this problem, we have limiting reactant, excess reactant, and we are also calculating the leftover. All right, so let's read the problem. Calcium hydroxide reacts with hydrogen chloride to create calcium chloride and water. If you place 2.8 moles of calcium hydroxide into 6.3 moles of hydrogen chloride, what is the limiting reactant, what is the excess reactant, and how much is left over? How much excess reactant is left over? So we're going to start out with the balanced equation, and look at the information which is given in the problem. We are given 2 points, so we are mixing these 2.8 moles of calcium hydroxide and 6.3 moles of hydrogen chloride. You can write here 6.3 moles here. of hydrogen chloride is given, and your what another one which is available moles of calcium hydroxide is 2.8 moles. Well, when you look at the balanced equation is telling you for every 1 mole of calcium hydroxide used, you need 2 moles of hydrogen chloride, right? But in the problem, you have to figure out by using these many moles of calcium hydroxide. If you're using these many moles, how many moles of hydrogen chloride will be used or will be required for this reaction to occur? And out of these two substances, which is going to limit our reaction? Which is going to run out first? 2.8 moles of calcium hydroxide or 6.3 moles of hydrogen chloride. So here is the equivalent again, and this equivalent, these numbers, they are coming from the coefficients of a balanced equation, and we get mole ratio from coefficients of the balanced equation. These are the mole ratio. Which fraction are we going to use? Again, depends on the problem. Like for which one are we solving? Are we solving it for calcium hydroxide or for moles of hydrogen chloride? So we can start with converting the given moles of hydrogen chloride to moles of calcium hydroxide. So here, let me put this here. Alright, so what are you given here? You are given 6.3 moles of hydrogen chloride. I'm going to write here 6.3 moles of hydrogen chloride. Alright, now what do you have to find? You are converting the available moles of hydrogen chloride to the needed moles of calcium hydroxide. Meaning how many moles of calcium hydroxide are we going to need in this reaction when we use 6.3 moles of hydrogen chloride. So what are you determining? You are determining the moles of calcium hydroxide. So that has to go at the top. So when you pick the fraction from here, this is the one you're going to pick, correct? That's the mole ratio. So I'm going to write here, for every 2 moles of hydrogen chloride used, we need 1 mole of calcium hydroxide. And this is coming from the balanced equation. This is our mole ratio. You solve it, you are going to get 3.15 moles of calcium hydroxide. And these are the moles which are actually needed. Okay, but look at the problem. We need 3.5 moles. This is what we need, 3.15 moles of calcium hydroxide. However, in the problem, we are given only 2.8 moles of calcium hydroxide. So this is actually less than the required moles. So this is going to use up first. This is going to limit our reaction. So calcium hydroxide is our limiting reactant, right? Why is the limiting reactant? Because we need 3.15, but in the problem you're given only 2.8. That's the available amount. Only 2.8 moles of calcium hydroxide is given. However, you need 3.15, which is more than what is available. Okay. Now, if this problem was just to determine the limiting reactant and excess reactant, you could have just stopped here, and you could have said, okay, so calcium hydroxide is our limiting reactant, so hydrogen chloride will be our excess reactant. However, this problem is asking you how much is the leftover. So you actually have to determine the moles of hydrogen chloride needed as well. So let's convert the given available moles of calcium hydroxide to the moles of hydrogen chloride needed. So how many moles of calcium hydroxide are given in the problem? It is 2.8 moles of calcium hydroxide, right? Right here, 2.8 moles of calcium hydroxide. So let me write that down. So we always start out with the given and we are multiplying with the mole ratio. So this is your given. Okay, and when you pick the mole ratio, now you know you want to figure out the moles of hydrogen chloride. So when you look at this fraction, in this fraction, moles of hydrogen chloride are at the top here. Whenever you pick fraction, you pick the one with the wanted or the desired unit at the top, and this is what you want, moles of hydrogen chloride. So now you're going to use this fraction. Okay, so here you go. For every 1 mole of calcium hydroxide used, we need or we consume 2 moles of hydrogen chloride for this reaction to occur. Now when you solve it, cancel the same units. Also here also, don't forget to cancel the same units. When you solve this, you're going to get 5.6 moles of hydrogen chloride. And these are the moles of hydrogen chloride that are needed and will be required or are used when required to react when you are using 2.8 moles of calcium hydroxide. Now let's look at the problem. So this is 5.6 moles of hydrogen chloride is needed. However, in the problem you are given 6.3 moles of hydrogen chloride, right? So this is more than what you need. You are given more than what you need. And how would you, so that is actually our excess reactant. Once again, it is 6.3 moles of HCl which is given. So this is more. So our HCl is excess reactant. So given amount is more than what you need. That is why it is the excess. This one is the excess reactant. Now how would you figure out that how much is the leftover of this excess reactant? You are going to subtract these. So what are you going to subtract? You are going to subtract the needed moles from the given moles. So given moles are 6.3, okay, and the needed moles are 5.6. Subtract them, you're going to get 0.7 moles of HCl. So this is the leftover after the reaction completes. Okay guys, you need to practice. Practice is very important. Yeah, let me put the period here. Please read these statements and pause the video. Tell if which one of these are true and which of these are false. And if you said all of these are true, you are right. Okay guys, I hope the video was helpful. Thank you for watching.